So delighted that Fraser's agreed to speak about certifying authority. I mean, he's been chair of the IMS certifying authority for a number of years. And the reason we wanted to put this presentation in today is a couple of reasons, really. One is there are a few of you certainly online who are coding examiners. I think you might actually be slightly surprised by some of what Fraser has to reveal and the nature of the work that you undertake. And I think that always surprises people. And those of you who are not coding surveyors, we'd be keen to try and encourage you to look at this maybe. We're always keen to encourage younger surveyors to come on board. The age is forever getting older. So Fraser's going to make a compelling reason why you might consider coding, I hope. Over to you, Fraser.
Does that screen look correct now?
Looking good to me.
Okay, so, hold on. I can't see it though, hold on. I need to do something. Okay. So, an introduction to certifying authority surveying. These things are always difficult because one never knows who's attending, who's listening, whether we're talking to people that do lots of code surveying and know it inside out, or whether we're talking to people that have never looked at a rule book in their lives. So I've tried to pitch this at something in between those two perspectives. I'm going to whiz through these slides probably and then stop a couple of times and see if there's any discussion before we get to the end. What is coding or certifying authority surveying? Just what is it? Well, any vessels, ships, workboats, charter yachts, any vessels operating at sea for commercial purposes are required under merchant shipping legislation to have a valid load line certificate. Prior to the early 1990s, that didn't really get applied to under 24 metre or under 150 gross registered ton vessels in the UK. We now have codes of practice that are essentially an equivalent to compliance with load line rules. How do certifying authorities get authorised? So, if you do work for a certifying authority, you are being a government surveyor. You're authorised under your contract with your certifying authority, and your certifying authority is authorised under contract with the Maritime and Coast Guard Agency, part of the Department of Transport. The contracts that all the certifying authorities work under are the same and are pretty detailed in terms of how they require us to go about things and how they require us to approve and continually assess surveyors. What size of vessels are we talking about? We're talking about everything and anything used commercially that is under 24 metres load line length. So that means it cannot be 24 metres load line length. 23.999 recurring is okay. 24 is not. One of the things that comes up regularly in MCA audit is checking that vessels are all under 24 metres. And the thing that is apparent is that if one misadvertently ends up issuing a code vessel certificate to a vessel over 24 metres, the certificate is not valid, the vessel is proceeding to sea illegally, its insurance is probably invalid, all sorts of things. So the 24 metre load line length limit is pretty key. What is load line length? So it's either 96% of the total length on a waterline at 85% of least moulded depth, or from the foreside of stem to the axis of the other stalk on the same waterline, whichever is the greater. So that's a bit of a mouthful. If a boat is anywhere near 24 metres load line length. Normally, if it's over 24 metres overall length, certifying authorities will all want good, clear evidence that the load line length is under 24 metres. We do certificate boats up to 28, 30 metres overall length sometimes, but that's going to require either detailed, accurate drawings confirming load line length, drawings of known provenance, or if drawings aren't available or can't be properly attributed to the boat, it's going to mean surveyor who knows what he's doing actually going and measuring the vessel. Measuring load line length can be quite tricky and time consuming and therefore quite expensive for owners. What are all these codes of practice? There's bloody hundreds of them now, nearly. So we've got a 1993 blue and yellow code for small commercial sailing and motor vessels. We've got a 1998 red code for small vessels operating from a nominated departure point. Those are probably each something like 50, 60 pages. We've got a 1998 brown code for small workboats and pilot boats. It's more, I think off the top of my head, it might be 150 pages. The codes for vessels operating commercially for sport and pleasure and for vessels operating commercially as workboats, where the people on board are being paid to be there, are different and are enabled by different merchant shipping legislation, which is all kind of key in keeping these things separate. So we've got those three coloured codes. We've got an alternative standard MGN 280 introduced in October 2004, which was bringing all the codes together, blue, yellow, red, brown, all in one book. Blooming complicated because you had to know everything about the boats you didn't want to code, as well as the boats you did want to code, so that you could work out which parts of MGN 280 were relevant to your vessel. There's now a new workboat code from the 1st of January 2019, and from that time, new workboats can't use MGN 280. There was an industry working group technical standard that ran from June 14 to 1st of January 19 that was used for workboats and pilot boats, which was issued by the MCA because the new workboat code edition 2 that was being written wasn't ready when it was supposed to be. So this interim standard was issued. Probably not a good thing. And we now have workboat code edition 2, which is legally enabled by a statutory instrument. It's a follow-on from that industry working group technical standard. It was issued on the 31st of December 18 to be used for all new workboats or newly coded workboats from the 1st of January 19. So it's not been on the go 2 years yet, and it's already in the process of being rewritten by the MCA. There are some other codes that we don't come across much. There are police boat codes brought in December 2009, which are very similar but a bit different, which certifying authorities are authorised to survey against. There's a small hovercraft code brought in February 14, which again we're authorised to survey against, but very specifically only if we can demonstrate that the surveyor who is going to survey a small hovercraft has clear and relevant experience. There is an inland waters small passenger boat code, which is a voluntary code, which gets used for boats that don't proceed to sea, as in don't go beyond categorized waters. There are a host of other standards. This is all the depressing bit I'm telling you all at the minute. There are a host of other standards. So there's EU Recreational Craft Directive. The codes refer to many of the ISO standards. Some of them are allowed to be used as equivalencies to code requirements. Others may be used, such as stability ISO 12217, but require different methods of verification or validation. James was talking just a minute or two ago about ISO standard for gas systems, and that and a whole host of other EU standards are used for code vessels. So surveyors need to know all the ins and outs of the actual MCA codes of practice. They need to have a pretty good understanding of all the ISO standards that are referred to and can be used as part of the coding procedure. So we've got the codes of practice themselves, we've got a whole bunch of ISO standards, we've got MCA notices, MINs, MSNs, MGNs. We've got then MCA SANs, surveyor advice notices, and MCA OANs, operational advice notices. So all the M notices are usually easy to find. The SANs and OANs are not always so easy to find. They're usually pretty much on our IIMS website. Lots of these documents will apply to one particular vessel and not another. So you need to know which ones apply and which ones don't. Lots of reading. What kind of vessels are we coding or certificating? So we've got small commercial sailing or motor vessels, we've got workboats carrying not more than a ton of cargo, we've got workboats that may carry more than a ton of cargo, might be fitted with a crane or towing twice their displacement. We've got rigid inflatable boats, we've got purely inflatable boats. I don't think I've ever come across coding a purely inflatable boat, but you can do. All of these different vessel types have different requirements in the codes, and one needs to know and understand which requirements apply to any given vessel we're looking at any time. Materials of construction. Codes recognize particular materials of construction: steel, aluminium, GRP, FRC, wood. Codes do not really recognize HDPE. The MCA were quite surprised a couple of years ago, they said, to discover that there were lots of small boats going around built of HDPE that were coded. Concerns there are that the structural rules which are used weren't really written for HDPE, and that it can melt at a relatively low temperature. But there are coded vessels in HDPE. Ferro cement isn't recognized, so we need to be sure we're not going rushing off to code a vessel made of a material that the code doesn't recognize. Sea areas. So MCA's range and risk policy looks at how far from a safe haven a vessel is going to go. We've got area 0, unrestricted service, area 1 up to 150 miles, area 2, 60 miles, area 3, 20 miles, all from safe haven. And then we've got more restrictive. We've got 20 miles from safe haven, but only in favorable weather and daylight. We've got 20 miles from nominated departure point in favorable weather and daylight. And we've got to sea within 3 miles of a nominated departure point, never more than 3 miles from land. It is important to look at those practically as well as by the letter of the code and be sure that a vessel one is certificating is actually basically capable of operating those sort of distances. Sometimes boats that would appear with their ISO accreditation to be suitable for a particular distance are not really in practice. surveyor competencies. So certifying authorities are required under their contract with the MCA to categorize surveyor competence. So that means, first of all, we've got to assess it. We've got to assess competence for the different materials construction, for different vessel types that we've just looked at, and if a surveyor is going to be doing actual stability testing or stability calculation rather than just passing on the stability documentation, then that has to be assessed. There are a lot of regulations. It's a bit of a catch-22. The MCA say we're not supposed to authorize people unless they are competent with the codes. It's very difficult to get competent with the codes without doing some coding work. IMS provide training and support. What we have done until quite recently is normally been 2 days per annum, which have been full days, either out on a boat doing stability work or looking at practical aspects of coding, or in a classroom going through all the theory side of it. And we've done it in quite big chunks. From the beginning of next year, we're going to start looking at that differently and dividing the codes up into all the different sections of structure, stability, firefighting, fire protection, bilge pumping, life-saving equipment, etc., and taking an aspect every couple of months and going into that in detail. Some photographs, and then we'll stop sharing and see if there's any questions. So what we're talking about, boat types. Small commercial sailing vessel. There's one small commercial sailing vessel. Here's another small commercial sailing vessel. The two might take different types of knowledge and experience to survey. Small commercial motor vessel. There's one type. Small commercial motor vessel. There's another type. There's quite a lot of boats like that going around, which carry up to a ton of cargo and are what one would call simple work boats. More complex work boats. Different types of experience required. Pardon me. First of all, obviously, knowledge of steel construction generally for boats like this. Then you've got heavier, chunkier machinery, you've got hydraulic systems, you've got quite often 3-phase 440 volt systems, you've got cranes, you've got winches, you've got loader regulations and all sorts to take into account. You've got load testing of lifting appliances, you've got annual inspection by a competent person for lifting appliances. So there's a lot of specialized knowledge required for a boat of this type. These sort of crane barges are usually limited to 7 degrees heel with the crane in operation. If you've done a lot of offshore sailing, you probably think 7 degrees heel isn't very much. It feels like quite a lot when you're on the deck of a boat with a big weight suspended off the end of a crane. Pilot boats.
No digo que quiero saber si es normal que tenga la sensación de que sea como.
So there are various different additional regulations applied to pilot boats. Kind of interestingly, they are the only type of vessel in the code where it specifies time intervals for pulling propeller shafts and looking at them. So you might have two identical vessels, one of which is doing a pilot boat roll and one of which is doing a pleasure commercial vessel roll or a simple workboat roll. One of them requires its shafts pulled every 3 years, and one of them there's no specific requirement. different vessel types still. So previously was dedicated pilot boats, then we have workboat with pilot boat endorsement. And again, there are just slightly different regulations. Most of the additional rules for pilot boats apply to a workboat with a pilot boat endorsement, but not all of them. Rigid inflatable boats, different kinds of boats. So different and specific stability and buoyancy requirements. Requirements for over 8 meter boats to comply with SOLAS, or that should be ISO, and it should be 6185, apologies. So SOLAS and ISO standards and particular requirements for inflatable collar or sponson testing. It's supposed to be a 24-hour test, and then a specific overpressure test for a shorter period. Bigger rigid inflatable boat, except just thinking about vessel types and what type of vessel a boat is. You're going to code a boat, you need to have a good understanding of which set of rules it's going to comply with. These boats, although they look like big ribs, are not ribs. They're decked vessels that comply with the freeboard requirements for a decked vessel. They were operating in category sea area category 1. You can't have a rib in sea area category 1. Another type of rigid inflatable boat, except not inflatable. But those boats were built to comply with rib stability and buoyancy requirements and were coded as ribs. Police boats. 3 different sets of codes for police boats, and just more detailed reading required. I'm just going to stop screen sharing for a minute. So does anyone want to jump in with any comments, questions at this point?
Feel free to jump in, anybody, or use the chat feature.
If not, we'll just keep banging through it. All I'm trying to do is really give a bit of an overview about what all is involved in certifying authority and code vessel surveying. So we'll go back to screen share and push on for a bit. Taking an inquiry for a survey of a code vessel. So the first things I always say to any owner are that we need to look at the hull design, hull and deck structural design. We need to look at the stability. If the boat is for some reason not going to pass the structure or the stability requirements that apply to it, nobody's going to get a lot of thanks for going and spending hours surveying the boat and writing lists of life-saving appliances requirements or getting hoses changed. So the first 3 key things really are on the hull and deck structural design, compliant with stability requirements, and then seeing that the structure itself is in good condition. There are a whole bunch of methods of approving stability and buoyancy. Some vessels require a full stability information book. Normally, if they're carrying more than a ton, if they're lifting or towing, if they're carrying more than 16 persons, carrying 16 or more persons, beg your pardon, and if they are in category 0 or 1. So if your boat requires a stability information book, that can be potentially very expensive. If there's pardon me, if there's a good existing lines plan, or there's already a computer model, and it's maybe reasonably straightforward. You're looking at a boat that none of those things exist for, you've possibly got to get lines taken off the hull either by measurement or by laser or whatever. That can cost anything of the order of £2.5 for a cheap stability boat, 3.5, 4 for a more moderate one, and if everything's required to be done, it could be 8, 9, 10 grand potentially. Simplified heel test for motorboats. So the difference between an inclining experiment and a heel test is the inclining experiment is providing details of centers of gravity for use in stability book calculations. The simplified heel test is giving you a pass or fail on the day. ISO 12217 stability. Motor and sailing, different parts of ISO 12217. We can use stops for sailing vessels for up to category 2 sail training operational stability. That requires proper and accurate measurement of the vessel, its sail areas. It requires knowledge of the vessel displacement and the keel weight. All of that information has to be valid. It has to have a reliable source. And the program that is used to run stops needs to be of known and reliable source. We've got different requirements for multi-hull stability. We've got perhaps not different requirements, but certainly different characteristics of stability in a swath vessel. And we've got an entirely different set of tests and trials for open boats and ribs, and generally requiring a swamp test. We've also got, in terms of thinking about swamp test, if boats that do have a deck don't meet the freeboard requirements, they're normally considered essentially to be open boats and need to be fitted with buoyancy. Sometimes old wooden boats can pass that because they're made of wood and there's enough buoyancy in them to keep them afloat. Sometimes boats don't pass, and usually swamp test calculations are done just by calculation. I would normally get a boat weighed and calculate its buoyancy against weight rather than trying to fill it with water and causing all sorts of damage to machinery, electrics, etc.
Fraser, it's Mike. Can I pop in with a couple of questions that have been popped up?
Yeah, do.
Chris would like to know, can you be approved for one specific category, for example, inland water, small hire boats?
So, two answers to that question. Yes, one can be approved for a specific category, and the code vessel fleet is, I think, something between 5,000 and 7,000 boats. I've forgotten exactly. Of that, the majority of coded vessels are probably vessels used for sport and pleasure and made of fiberglass or GRP, FRC. So most code surveyors are probably approved for those vessel types. And if we approve surveyors, most often we will approve them for those first level vessel types rather than for the whole shebang, unless they come with a great deal of knowledge and experience. The second bit of the question, I did touch on the code of practice for inland waterways, which is a voluntary code. I mention it because it's there and it exists and it's useful to know about. It is not actually a code that certifying authorities are authorized to, under their contract with the MCA, to survey or certificate against. So Well, I mentioned that code is just for information purposes. We don't approve anyone specifically to survey against the Inland Waters Code, and we don't issue certificates for it. You had more than one question, Mike. Hope that's answered.
Yes. Mark asks, on a new build, the Classification Society would have to oversee the inclining experiment and prepare the stability report. Therefore, does this mean the appointed independent surveyor is there only as a second set of eyes, or must she also prepare a set of notes?
So that's not entirely correct. For any vessel, new build or otherwise, if it's a boat that requires a stability book, the stability book has to be prepared by someone who is competent and approved by the certifying authority that the vessel is being coded under. We have, I don't know, 6, 8, 10 different people that we have received stability books from that we know and approve, maybe more than that. The official position is that the inclining experiment is supposed to be witnessed in terms of coding. The inclining experiment is supposed to be witnessed by the certifying authority surveyor. So it should be undertaken by a competent person. Now that might be your class surveyor. If the vessel is being built to class and there's a class surveyor involved, that might be your class surveyor. But boats are not always built to class, and there is not always a class surveyor involved. And we have boats that are coded on the basis of 5 years safe history, perhaps, or on the basis of complying with the requirements of class structural rules, but not certificated by them, where those same vessels have had to have a stability book. And normally the inclining experiment is undertaken by the owner's stability consultant and witnessed by the certifying authority surveyor. Hopefully that answers the question.
I've got no comeback, so I assume it has.
Anything else, or shall I keep going?
Keep going, please, Fraser.
So, still on the subject of stability. So what the code says about stability really is that it is incumbent upon the owner or managing agent to provide the certifying authority with evidence of the vessel's stability compliance. That might be a stability book. Not all surveyors are familiar with stability books. You don't have to be absolutely in depth, and you don't have to be approved to do an inclining experiment or a heel test or any other aspect of stability. You can just be the surveyor who is looking at the boat against the set of rules and passing the stability documentation into the certifying authority to be checked. So what the surveyor does have to be able to do is see that the boat is actually configured as described in its stability documentation. On a boat with a stability book, for example, that the watertight bulkheads, sometimes we find ourselves with approved stability books, all look great on paper, and then you go and look at the boat and find that there's a watertight bulkhead not on the boat that is in the book, or that the watertight bulkheads are in different positions on the boat than they are in the book. On me. So all of that needs taking into consideration, thinking about. Going back to the onus is supposed to be on the owners to provide the stability data. Very often they need help with that. They don't know what they're looking for. They don't have it. They don't know where to look for to find it. And we do generally all try to help with that. If there is existing stability data, sometimes boats that are built under the Recreational Craft Directive, one sort of knows where designed, or the first of type was designed to comply with ISO 12217, but there is supposed to be specific evidence of that for the individual boat one is looking at. And there should be, if we're using that, there should be the EU nominated notified body first of type approval certification and a builder's declaration of conformity and builder's certificate. So we can help owners find all those things, but we need to think about how we recover costs for all that and the time involved and everything else. We also have to bear in mind that stability data, like everything else, goes to the certifying authority, gets checked and scrutinized, and if it's either not correct or not directly attributable to the vessel, it might not be approved. Testing such as inclining experiment, heel test, stops measurement and such like is supposed to be undertaken by someone with proven technical competence that we as a CA have approved to do it. Methods of approving structural design. So there's some grey areas in this which certifying authorities and the MCA are trying to harden down on. Somebody touched earlier on class, and if a boat has been built, if it's a GRP boat, been molded, or a steel hull has been fabricated, if the drawings have been submitted to class and approved by class, and the hull and deck have been built under class survey and there's a class certificate issued, that's straightforward. All we need to do after that is see that the structure is still in good condition. The grey area is the second line. A vessel structure is in general accord with the standards of the load line authority, i.e. class, Lloyd's, DNV, GL, whoever. And sometimes there are grey areas in how that is, or in the past has been accepted. But we are all now pretty much looking for clear, proper evidence that this is either an absolute sister ship, it's been built in the same shipyard or factory, it's got a yard number or a pin SIN number that can be traced back to the first approved vessel, all the rest of it. Structure on simpler vessels can be approved by 5 years safe history in similar sea and weather conditions. There are quite a lot of boats around that are approved on that basis. It wasn't looked on very favourably by some of the overseas administrations where we had workboats operating, German and Dutch in particular, and partly as a result of that, that has been removed completely from the Workboat Code Edition 2, which is probably okay and sensible for the bigger wind farm workboats and crane barges and things that were in mind when that decision was made, but it's quite difficult for smaller vessels that are perhaps, you might say, technically workboats, ribs and small boats that are workboats because they're carrying people on board who are working. Yeah, you can have also, the structure is exactly as another vessel with 5 years safe history, but if that route is going down again, it's not allowed under Workboat Code 2, and one would now be looking for clear documentary evidence of that. Others are allowed to submit calculations, drawings and materials, construction and everything else to the certifying authority for approval. That's an area that's under quite a lot of discussion. How does a certifying authority do the approval? You can do it against first principles, or you can do it against a published set of class rules or regulations. Most of the class organizations are now taking the view that they are the only people that can say whether a vessel complies with their rules and regulations. We had a full certifying authority training day on just that 2 or 3 weeks ago. And one of the things that was mentioned there was that class approving a hull and deck structure doesn't just start with the drawings and the work. It starts with approving the workshop, approving the quality assurance procedures, all sorts of things. Me. Other methods of structural approval, ISO 12215, relevant parts, or for a rib, SOLAS or ISO 6185. So again, this is really just meant to be a bit of an introduction to what this is all about. And what I'm kind of just highlighting here is that there are a plethora of different ways of doing it, but they're not all open to every vessel. So we have to know which method of structural approval or which methods of structural approval are acceptable for the specific vessel under the specific set of code rules and regulations we're working to. Life-saving equipment generally depends on sea area category, numbers of persons, sail or motor powers. There are additional requirements for pilot boats. If EPIRBs or SARTs are required, they should be in date, and we should normally seek to test them when we're doing our survey. And small item, but something I still come across regularly as not being there. Vessels are all required to have a training and instruction manual covering the use of all the life-saving equipment, and with a record in it of inspection and any onboard servicing of life-saving equipment. Life rafts. So the first thing is they are required on all code vessels. I quite often get people with ribs saying, do I really need a life raft? And the answer is, yes, you do. The raft itself has to be suitably approved, which might be SOLAS, MED, TFT perhaps, but more commonly now ISO 9650. The raft might have a canister or a valise case. If it's a valise case, it has to be in a dedicated locker protected from the weather. If it's a canister, it can be in a locker or on deck.
Yes.
Is somebody cutting in?
I'm just trying to mute them down, Fraser. Keep going.
It's all right. I thought it was a question coming in. So we've got the life raft itself. We've got what its outer casing is. We've got the approval standard for the life raft, which might be different for different sea area of operation for the vessel. We've got the safety equipment pack in the life raft, which is supposed to be a SOLAS A or SOLAS B pack, depending on the sea area. We've then got that SOLAS B pack for vessels certainly up to category 2 is allowed to be partly in a grab bag. We get ISO life rafts that come with under 24-hour packs, over 24-hour packs, SOLAS packs. You need to know what is in the life raft, which you can only know from its certification, in order to know what's supposed to be in the grab bag, so that you can inspect what is in the grab bag that's on board. And you need to be careful, because life rafts sometimes seem to say that they have a SOLAS B pack. When you look at it more closely, it says that there is a SOLAS B pack associated with the raft in a grab bag. So then we've got, on different vessel types again, some rafts require annual servicing, some rafts are allowed to be per manufacturer's recommendations. We've got, which I've not put down here, but ORC rafts have been being phased out over the last couple of years, and again, depending on the sea area of operation, you've got a different length of time that any ORC type raft is being phased out over. So we need to know a lot about life rafts and all their approvals and certifications and contents. Talked about all that bit other than the life rafts on open decks. Life rafts, according to the MCA documentation, are required to do two things: to float free if a vessel sinks, or to be able to be physically launched in an emergency situation. So the MCA defined float free as being fitted for the hydrostatic release. There are some occasions where perhaps a hydrostatic release might not be absolutely required, but 99% of the time on a raft on deck it is required. So we then need to know things about hydrostatic releases. We need to know what they're usually small hydrostatic releases on these under 24-meter vessels. They're usually got a time expiry. There's usually a specific way that they have to be fitted, with life raft pinchers connected to the weak link and all that sort of thing. And very often you see them not fitted correctly, which kind of defeats the point. Life rafts on ribs. So cover the point that ribs do require a life raft, same as any other boat. Quite a lot of ribs doing whale watching and general sea tours and things like that. They want to carry 14 persons, so the code allows a maximum of 12 passengers. It allows the number of crew that are necessary to operate the vessel. We do have coded vessels that have up to 24 persons, where there are 12 crew and 12 passengers. But that's not bending the rules. That's when it is absolutely correct and sensible that the crew requires 12 people. And if you have watchkeeping and things like that, that can quite often build up quite quickly to those numbers. But coming back to life raft, ribs that want to carry 14 persons. So the ORC rafts, you could get an ORC 14-person life raft. You can get life rafts, SOLAS life rafts, certainly for 16 persons. I'm not quite sure about 14, but you can certainly get a 16-person SOLAS life raft. But they're huge and bulky and would have to fill a rib. The next option for most ribs is the ISO 96501 standard life raft. And that standard only goes up to 12 persons. So if you see a life raft that says it's ISO 9650 and says it's for 14 persons, it isn't compliant because it doesn't meet the standard, because the standard's only for 12 persons. That means you end up with your 8.5-meter rigid inflatable boat possibly needing 2 life rafts, and suddenly it hasn't got room for 14 people anymore. So it's all a bit tight and difficult.
Fraser, it's Mike. Another 5 minutes. Is that okay?
Yeah, probably.
Okay. Thank you.
I'll be quick. Engine space insulation. It's supposed to be non-combustible. Very often it burns, in which case you've got to get people to take it out and change it. Fire protection for boats with more than 750 kilowatts of power. Steel or fire-resistant GRP. Fire extinguishing rules and regulations. Fire pumps, fire extinguishers, fixed fire extinguishing in engine spaces. Fire extinguisher capacities based on fire ratings, not on weight. We ought to know about and understand fire extinguisher fire ratings and systems. Fire extinguishers to be serviced annually. And extended tests normally every 5 years, and hydraulic or pressure tests every 10 years. Requirements for radio communications. Bulwarks and guardrail heights and spacings. Seating on ribs. We'll just skim past for the minute, but while it doesn't absolutely say so in the code, most of the time we're going to need fixed seats for all the people on board. spars, rigging and chain plates all to be looked at every 5 years. Sometimes getting access to see the chain plate to hull attachment can be pretty difficult in terms of dismantling and opening up. Storm sails, storm jibs, deep reefs, trysails. Accident reporting. Owners are supposed to report any and all accidents and incidents. If there's any significant damage, we have to survey it, and the vessel isn't allowed to operate until it's been satisfactorily repaired and signed off by the certifying authority. A few quick instances of damage. This is a 120-meter cargo ship that went up on the rocks and got written off. That's a boat that belonged to a customer of ours. It went to the Channel Islands, forgot about the high tides. That's just a bit of a laugh. That boat, if you can't read it, it's called Temporary Insanity 2. That's one everyone will have heard about probably. Steam's supposed to give way to sail, but not in narrow channels. Classic yachts. There's a bit of a costly repair or two involved there. That's probably repairable. I've repaired boats like that, but most insurance companies will now just write that off. As we talked about already, we're supposed to check and approve the competence of all surveyors. IMS provide training and support. A member at any level can apply to the certifying authority. I'd say it's a good idea to attend our training a few times first and to have read and reread the rules till the cows come home. We ask people to submit condition survey reports, practice SCB or WB2 coding reports, and to attend an interview. So, with all that plethora of rules, regulations, whatever, is it worth bothering with? Well, I think it's all quite interesting once you get into it. There are thousands of coded vessels, so it is a good business avenue. If a one-man band small marine survey business might turn over anything from maybe 50k to 250k, you might make up a third or even sometimes half as much of that work from coding. So if you invest the time and effort into it, it can provide financial rewards. Is that my 5 minutes up?
Spot on, Fraser, I'd say, yeah. So, anybody got any questions on coding?
So that was a very quick rattle through what coding's all about. People that do coding will hopefully know most of that already. People that don't be put off. It is worth looking at, but there is a lot of work you do have to invest in it.
Yeah, it's a complex process, isn't it? And with coding examiners all over the world, actually, they're not all UK based by any means. So that's worth pointing out. I'm trying to think, we've got some people in the Caribbean, somebody out in the States, I think from memory, quite a lot dotted around Europe. So you don't have to be UK based. I agree with Fraser, it is an interesting avenue. It's challenging, isn't it, Fraser? That's the bottom line, but rewarding if you get it right.
Would be easier if the codes were themselves rather better written and more straightforward.
I couldn't possibly comment.